All right, welcome back. So in this video, we're going to be working on the paddle. Now, the ball in the previous video was able to bounce around and we turned that functionality off. Now what we're going to do in this video is migrate that launch call and that is playing equals true into the paddle's functionality. But we're also going to make the paddle be capable of moving left and right, and also when we press the space bar, it will fire the ball into the scene. So in order to do all of that stuff, we need to start writing code inside the paddle script. So if we come down here to our script section and find the paddle, go ahead and double click that. And over here in this code, we want to do basically similar to what we did with the ball just a second ago. We have our section up here at the top where we're going to reference all of our rigid body and have some settings as properties that can be adjusted potentially in the inspector. So we have our fields section. And this first item is going to be a rigid body, also called RB. We need a serialized field so it can be seen in the inspector. And it's going to be a float called speed. And the paddle is going to be a little bit faster than the ball, so let's set that to 15.0f. And just like with the paddle, we're going to calculate the direction, just like with the ball rather, we're going to calculate the direction the paddle should go based on whether or not you've pressed a specific key. So we need a vector3 called dir. And the way the paddle operates, since the ball was under its own kind of physics control as it bounced around, fixed update, and the velocity being modified all by itself based on applied velocity, the paddle is actually slightly different. The paddle is going to listen for inputs, and the best place to listen for inputs in terms of something like get key, where we're listening for it every single frame, is inside update. But when you're dealing with physics, you should be handling physics updates inside fixed update. So right there, we have two separate methods. So the question is, how do we bridge the gap between those? Well, we're going to set up we're going to produce a request based on the fact that you're pressing a key, and then we're going to consume or process that request over in fixed update and actually apply the physics. That way, we only ever make the request once and process it once. Again, because fixed update can potentially be called multiple times or every other time or whatever your timestamp is set to, we allow for the system to just kind of sort itself out. It only ever updates the one time. So here inside start, we need to gain access to backing it up, going over here to our, right after our direction, we need to establish a couple of variables that will allow us to determine whether or not you've requested for the paddle to go left or right based on a key press. So we need a couple of bools. So bool, and I'm going to call these left rec, as in request, left request, comma, right rec, as in right request. Now, the paddle is also going to be able to talk to the ball. So we need at least a reference to one ball out there in the scene. So just like our ball hit a brick and we talk to brick B, here I'm going to talk to ball B. And from the ball, I'm going to actually extract out some information. I'll be able to talk to it, for example, the launch method, I'll be able to talk to that, but then I also want to ask the ball for some specific information to help calculate the offset that it should be above the paddle. And so in order to calculate that offset, I really only need to ask for that information to calculate that value one time. So here I'm going to cache that value, so I'm going to have a vector3 called ball offset. Now down here inside start, I'm going to go through and see if this particular object, paddle, has a rigid body component attached to it. So rigid body, so RB, set that equal to get component diamond rigid body. And method, so parentheses and semicolon. And if we have found the rigid body, we need to change some aspects of it. First of all, the ball and the paddle have the exact same mass. So when the paddle and ball collide, the paddle scoots along because there's really nothing stopping the ball, right? There's no equal and opposite forces there. So all that force is going to be sent directly into the paddle. Well, the ball will reflect and it will go its own direction, but the paddle will actually kind of hop or slide based on the fact that it was just impacted by something of equal weight, of equal mass. So what I want to do is basically make this a feather striking a car kind of scenario. I want to crank up the mass of the paddle so that when the ball strikes it, the paddle just shrugs off the impact. So we need to tell the rigid body to set its mass equal to 1,000. The next bit I want to do is turn off the gravity so the paddle no longer falls to the ground. So RB.use gravity, set that equal to false. And very similar to the way the way the ball worked is the paddle is not going to go anywhere near as fast. So I don't need to change its collision detection mode, but I do want to constrain it in a couple of different ways. Actually, 3 different ways. Number 1, I'd prefer my paddle to not be able to climb up or down in the scene. So I want to freeze its position on the y-axis so it can't go up and down. I also, just like the ball, don't want it to go in or out of the scene, so along the z-axis. And then I also prefer it not to rotate. So in order to get all those items, I can talk to rigid body, so RB, dot constraints, and set that equal to, and in this case I'm going to drop down onto the next line because, again, I run out of horizontal real estate here. And the constraints we're going to use, there are 3 of them. Rigid body constraints dot, I want to freeze position Y. And all I'm doing is using the filtering logic to kind of get close enough to the value. If you don't want to type that out, you just find freeze position Y. Now, just as before, I want to add one more item. So I need a single vertical pipe, or vertical bar rather. And on the next line, I need one more rigid body, constraints. And this is going to be freeze position Z. So freeze position Z. And then I want to add one more, so another vertical bar. And on the next line, we need one more rigid body constraints. And this is going to be freeze rotation, the whole thing. But F rot, well, okay, that worked. Sometimes the wording kind of matches some of these other letters. So in this case, it did work. So frot got me to freeze rotation right here at the top. It's not one of these 3, X, Y, or Z. So pick freeze rotation and semicolon. It's also important to note, just as a side note, if you mess any of these values up, Y, Z, rotation, and the same thing with ball, up here at the top, Z and rotation, then when you start playing, these values will supersede your transform. It will actually cause your ball, even if you're telling it to go somewhere, or your paddle, even if you're telling it to go somewhere, it won't. It locks that value down. So it kind of overrides the way the physics internally will update. So if your object isn't moving, this is one of the first places to check. Make sure you're using the proper freeze rigid body constraints. Okay, so now that we've frozen the various constraints, now I want to look through my scene and try to find a ball. Now, it's worth noting that the original Arkanoid, it had power-ups that would increase or decrease the width of the paddle. It could add lasers. It could make it magnetic so that it latched the ball directly to it. It also had power-ups that would increase or decrease the ball's size. It also had power-ups that would allow you to have multiple balls spawned into your scene. And so you could lose almost all of them. I think you had to keep one still in the scene. If you lost that, you lost. But otherwise, you could have multiple items out there. So the idea, the point of this is that if you have the intent of making some kind of power-up like that, ball B up here at the top would have to then change to a ball square brackets B. It would have to become an array. And right now, it's just a single variable. So down here inside start, when I go looking through my scene, if I had multiple balls in the scene, I would need to change the way I looked for them. So I want to fill in the B variable with some ball out there in my scene. And in order to find that, I don't necessarily know what its name is, right? Even though it's called ball, sure, it's also very possible that its name might change. You might change its name to some other kind of descriptive thing, and then GameObject.find wouldn't necessarily find it. But just like we did with the brick, as well as these get components for rigid body, we can also look for the specific type, the actual teal looking type. And the ball is a type. So we can use a method called find object, and notice there are multiple versions here. Find objects, the plural version down here returns you an array, but the version I'm going to use returns me a single object. So find object of type. What type's it looking for? Well, inside the diamond, let's say we're looking for a ball, and then parentheses because it's a method. And for some reason it picked the S version. So again, here if I mouse over it says cannot implicitly convert an array of balls to one ball. So I need to get rid of that S that for whatever reason got kept around. So now that that S is gone, the line doesn't have any issues. So now that we have a ball and we have the paddle, we can now ask for some information in order to calculate the ball offset. So it turns out that your cube, the square on the 2D plane that represents you, or the circle that's the ball or the sphere in 3D, you can ask them for their width and height, but you can ask them for their half space width and half space height from the center out, left or right or up or down. And the same thing is basically radius coming from your ball. So if we ask for that information, if I take from the center of the paddle up to the top, and then I take the radius of the ball and I add those two numbers together, that is the exact offset from the center of the paddle to the center of the ball to make it look like the ball is resting perfectly on top of the paddle. So in order to calculate that, what I want to do is fill in the ball offset Y, because the X is, remember, it's going to be wherever the paddle is horizontally. So I'm not worried about X, but ball offset.y, we need to fill it in with some information, the combined information from both the paddle and the ball. So I can set that equal to, it turns out where we get that information from, there's like 3 different spots in Unity. The one that works for this is coming off of the renderer. So get component, and we're going to target the renderer, and get components a method. So off this method, I need to ask the paddle for its entire bounds, the entire shell that represents its area. So that's bounds. And from the bounds, I can ask from the center out in any direction. So this is the half width, half height, and that is the extents. And now I can ask which extents, TS. I can ask for the height or the width, or Z, but we're not going to use Z. So I want the height, and that's going to be Y. Now I need to add that to the same information coming from the ball. And it turns out, since it's going to be the exact same get component renderer bounds extents Y, but it comes from the ball, I can select from G all the way to y, copy that, and right after the plus, I'm going to drop down to the next line. And I said I'm now talking to the ball, so b dot, and then just paste, semicolon. And get rid of that extra line that it added in there for some reason. So now it's b dot get component renderer bounds extents y. So we're getting the paddle, its half space height, and the ball's radius. Add those two numbers together, and that gives us an exact y offset. So now, down here in our update, we want to listen for key presses. If you press the A or left arrow, you're requesting to go left. If you press D or the right arrow, you're requesting to go right. So we need to ask the input system for those checks. So if input dot get key, and here notice I'm going with get key, not get key down or get key up, because up and down are polled only for that frame. They return true for the first time that the key is either pressed or released. I want to be able to ask if you are currently pressing and holding the key down. So that's what get key does. It polls every single frame. So get key, and the key code that I want to look for is A. But then between these last two parentheses, I want to compare, logical OR, say if I'm pressing A or if I'm pressing left arrow. So I need two vertical bars, and then on the right-hand side of those two vertical bars, but before the parenthesis, I need to ask input if get key for the key code left arrow. So if left arrow is depressed or A is depressed, then we can, in our body, say left request equals true. You have made a left request. Now, after this if statement, I'm going to drop down a couple of lines and say the same thing but for the right. So if input dot get key, and the key code is going to be D, or input dot get key, and the key code is going to be right arrow. So if we're pressing D or we're pressing right arrow, then inside the body we are requesting to go to the right. So right request equals true. Now, after those two if statements, I want to listen for whether or not we've started playing the game, right? If we're not playing the game, we just loaded into a level, we're kind of lining up our shot, moving the paddle left and right, kind of eyeballing it and getting ready to press the spacebar. But we haven't pressed the spacebar yet, so we're not playing. The game manager is playing will return us false. While we're not playing, I want to map the ball to the paddle and include the ball offset that I calculated earlier. Then when you press the spacebar, I want to launch the ball, and I also want to tell the game manager that we're now playing. And since I was, just a second ago, only updating the transform of the ball based on the fact that we weren't playing, that will no longer happen because we are playing. So I'm going to use the is playing as a toggle to turn off some code. So still inside update, but after my two if statements, we're going to have if not game manager dot instance dot is playing. So if we are not playing, then what I want to do is tell the ball to update its transform's position specifically, and I want to assign that equal to the value of this paddle, its position, plus the ball offset. So I'm going to add this. It's not necessary, but I'm going to add it anyway. This dot, so the transform dot position, that's the paddle's position, and add to it ball offset, semicolon. So this one line will update the ball based on the transform of the paddle, so the paddle's position, plus the ball offset. This gives us our X and a Y, but then we add more Y to it to set that position to that slide offset. So this will happen all the time while we're not playing. But if we press the space bar, then the magic happens. So if input dot get key down, and the key code we're looking for is space, as in spacebar, then we want to do two things. Basically the same thing as what's inside ball.start, or rather ball start. We want to tell the ball to launch, followed by telling the game manager instance is playing to be true. And the second this becomes true, when update comes back around, this will be true. Not true is false, so this if then fails to run based on the fact that we press the spacebar. Okay, so double check that your code is the same, that you're not getting any errors or anything like that. And I'm actually going to save just in case. And now that we've established that we want to go left or we want to go right, and we press the button to actually launch us, actually the launch us isn't relevant, it's just whether or not we want to go left or right. Down here at the bottom of the file, the last curly is the end of the class. I can see that by mousing over it. And this curly right here is the end of update. So I want to go just after update and add one more Unity method, very similar to start and update. So if I start typing fixed update, you'll notice I get several fixed related items, and a third one down is this fixed update. And by adding that, just like our on collision enter and all that stuff, we get private. And in here, we want to handle whether or not we, like how we go left and right. So just like our nudge if needed, the very first thing we want to do is the direction vector up here at the top that we're recalculating. I want to nullify that, right? So if you let your finger off the key, then we reset the travel of the paddle. It immediately stops. So dir.x, set that equal to 0. The next bit is to look for whether or not we've requested to go left. So if left request, then inside the body, we want to turn off that request. That way we don't accidentally continue trying to process it. So left request equals false. And once we've turned off the request, the final piece is to update the direction X based on our speed variable up there at the top. So dir.x, and we want to go, if we're going to the left, that's negative, so minus equals speed. Then after that if statement, we want to check for going to the right. So if right request, and inside the body, we want to do basically the same thing. We need to turn off the right request. So right request equals false, followed by, we're going to update the direction.x, and this time we're going positive. So dir.x plus equals speed, semicolon. And right after those two if statements, if we didn't change anything, the x will be 0. If we go left, the x will be subtracted. Let's see, negative 15 will be applied. If we go to the right, positive 15 will be applied. So if you think about it, if you press both keys at the same time, you'll go from 0, negative 15, and then positive 15, which brings you right back to 0. So this logic, pressing those two keys at the same time, will neutralize the direction by resetting it back to 0. Then we want to take the direction x, or more specifically in this case, all of direction, and feed it into our velocity. So rb dot velocity, set that equal to dir, direction. And save that file. So again, if you're getting errors or warnings or anything like that, double check, pause the video, look at this code, look at the code in the screenshot to make sure that everything that I've written and everything that you've written matches up exactly. So now that this file is saved, these other files are saved, we're going to jump back over to Unity. You're going to let that compile. Double check this. Yep. Let that finish compiling. And now if we press play, the ball should map directly to the top of the paddle. And if it doesn't, something's gone wrong, so please double check your code. Again, this guy right over here is not an error. It's using a warning to signify more of a heads up to you, a little more severe than a regular log, but it's on collision enter, but we weren't playing. And at the moment, even though the editor is playing, what I'm referring to when I say that the game is playing is actually here inside the code. If I move my cursor, if I move my paddle using A, D, left arrow, right arrow, you should be able to confirm that those items are working. If you press A and right arrow at the same time, the paddle nullifies its direction. Same thing with D and left arrow. It basically stops moving. So A, D, left arrow, right arrow. And now, since the ball is tracking, if I press the space bar, the ball now starts bouncing around the level. And I can still move the paddle around to kind of try to line up my shot. Right? And once the floor gets sorted out, then we'll be able to hit it and actually lose. And once we get some information inside the brick, we'll be able to hit it, gain some score, and then transition to the next level. So with that concludes everything for the paddle. And I'm going to go ahead and stop the video. And in the next video, we're going to resume with the logic that's inside the brick. So if you would, join me in that video in just a minute.